Hello class, welcome to Algebra Lesson 8.5, which is all about linear, exponential, and quadratic models. By the end of this lesson, you should be able to determine whether a linear, exponential, or quadratic function best models a data set. Okay, so let's quickly refresh our memories. Linear means that we have a straight line. So linear is when you have those straight lines. Exponential are the ones that kind of go up rapidly. I'll maybe draw. Okay, so we're going to learn today how to tell from like a table, a list of points, which of these is going to best fit our data. And it might not be a perfect fit either. That's why you have to look for patterns in order to see. Okay, so example 1, determine which function type represents data. So A, how can you determine, how can you determine whether the data in the table can be modeled by a linear function? Okay, so the way that we figure out if something is linear, we have to confirm that it's changing by a constant rate. And we do that by looking at what are called first differences. So if I look at my first y value, I have a -1. And then going to my second y value, -1 to a +1, that's a change of 2. Going from a 1 to a 3, that's a change of 2. To go from a 3 to a 5, that's a change of 2. To go from a 5 to a 7, that's a change of 2. And something I forgot to do before looking at all of that was to make sure that my x's were changing by the same amount each time. So you can see each time it was just going up by 1 for my x's. So since my x's were only going up by 1 and my y's were going up by the same amount each time, we know that this is a linear function, okay? So when your first differences end up being the same number over and over, that is called a linear function, or a linear function will be the best model for the data, okay? What if we're trying to figure out if something is a quadratic function? You look at something called the second differences. So the first thing you do, make sure your x's are going up by the same amount each time. So you can see each time it's just increasing by 1. Okay, so my x's are fine. Then my y's, I do 9 minus 3, that gives me 6. I do 19 minus 9, that gives me 10. Do 33 minus 19, that gives me 14. And I do 51 minus 33, that gives me 18. Okay, so that's how I got these red numbers here. Now, what I'm going to do is I'm going to say 10 minus 6 is 4. 14 minus 10 is 4, and 18 minus 14 is 4. Since all of these second differences match, you know that this can be modeled by a quadratic function. All right, let's look at this last table. We're going to learn about how to tell whether something is an exponential function based on a data set. Okay, so the first thing you're going to do is you're going to analyze your first and second differences. You'll notice that my first differences gave me 4 different numbers. And then if I look at my second differences don't match either. When this happens, that's a good indicator that you're going to have an exponential model. So what you're going to do is you're going to go back to your y column, so way back to the start here, and you're going to say my second term divided by my first term. 2 divided by 1 is 2. Then I'm going to say my third term divided by the second term. 4 divided by 2 is 2. I keep going. I say 8 divided by 4. That's 2. Then I move up again. 16 divided by 8. That is again 2. Since those are constant, those are ratios that are constant, we know that this is an exponential function, okay? Now, I want you to try this problem on your own. Determine, is this linear, quadratic, or exponential based on the data that you are given. Good luck. Okay, for this first table here, hopefully you did the first difference, saw that none of those matched, so you tried your second difference. And when you did your second difference, hopefully you saw that all of them equaled a -6. Since our second differences matched, that means that this is a quadratic function. Okay, this is the last one I want you to try on your own. Good luck. Okay, for this problem, hopefully you saw that your first differences didn't match, your second differences didn't match, but if you went back to the original y values and did the second term divided by first, third divided by second, and so on, you saw that you had a common ratio of 3. Okay, so that tells me that this is an exponential function. Okay, this is all I'm going to have you do from this section because you guys don't have the big fancy calculators yet. You'll get those in high school. So this is all that we're going to do from this section. You're just going to practice identifying linear, quadratic, or exponential functions based on first differences, second differences, and your ratios. If you have questions, please be sure to reach out for some help. I am happy to help you. Have a great day.